Ow, my knee. Sterling silver contains 925 parts silver and 75 parts copper by mass. What is the percent silver in the sterling silver sample? Okay. Well, to solve our percents, I know we went through this really fast, but I'm going to say Ag instead of writing out silver. Why? I messed up my knee. Okay. Ag is our symbol for silver. Our percent silver is equal to
225 parts.
Let's go for a formula first. Our amount of silver over the amount total. Is that it? Times 100. Do we know the amount silver? What is the amount silver? 925. Don't accept it. Parts silver. Is parts a unit we've talked about yet? No. So we might panic and go, oh, well, this is going to suck. I don't know how to convert parts. All right, but before we panic, let's write out the rest of this. What is our total amount? Sort of, yeah, I mean, 1,000 is technically the correct answer, but how did you get 1,000? 925 parts plus 75 parts. What does this then equal? 925 divided by 1,000 times 100, and we should end up with 92.5. A question was brought up about Sig Figs. So if we look at that question, 925 divided by 1,000, how many Sig Figs in 925? 3. How many Sig Figs in 1,000? Is a good response. Can I be looking at the Sig Figs in 1,000? I should not be checking for the Sig Figs in 1,000. Where did the 1,000 come from? From the addition of 925 plus 75. Okay. In an addition question, where's our Sig Fig? What's that? Still not hearing it.
Decimal points doesn't come from
The decimal point, so it's our least precise measurement. Not the number of Sig Figs, but our least precise measurement. Where's the least precise place in our 925 plus 75? The ones place. Which means, when I go to my final answer, the ones place is a significant digit. What does that mean about all the other zeros? They're all significant. So I've got 3 Sig Figs versus 4. My answer needs to be reported to 3 Sig Figs. Okay. Every time you do a calculation, you need to be watching your Sig Figs. Just because you wrote 1,000 doesn't mean that those zeros are now not significant. That 1,000 was a calculation, not a measurement. The measurement was 925 plus 75. Okay? So you have to be careful with propagating Sig Figs through a calculation. Those of you going, oh crap, this is going to suck dealing with this. Do we care? There's only one other measurement or one other answer that could possibly match our 925 if we dealt with Sig Figs, and that's the 100%. Would I really ask a question where we have this difference, where I'm asking about percentages and your answer just comes out as 100%? Probably not. The rest of them have nothing to do with Sig Figs. This is not a Sig Fig question. This is a percent question. Okay. So our answer is 925. We got our 3 Sig Figs. Okay, or not 925. What is that number? It's in a box. 92.5. Okay. The next big question here. You'll notice 12.3, 8.11, 7.5. Where did those numbers come from?
Maybe dividing the wrong way to do it.
What if you had taken 75 parts copper and divided it by 1,000? That would be 7.5. That is correct. That is not what I asked for. However, if you don't know what you're doing, what are you going to end up doing? Guessing and punching random numbers into the calculator and saying, does it show up as a multiple choice? Guess what happens? You punch random numbers into the calculator. I already did that. That is now an answer choice. Okay? You have to know what you're doing. Don't just punch into a calculator. Oh, the answer showed up. Why did the answer show up? If the test was written properly, that answer already was thought of and is written there. Okay? So it's not just does it show up. This is something you can yell at me for too. Most instructors aren't aware of this. I mentioned issues about cheating and ways to get around loopholes and all that fun stuff. I'm aware of the loopholes. I will close them when I think it's important. Dealing with calculations and getting through an exam is important. Punching stuff into the calculator will not get you to the answer. Odds are it'll get you to the wrong answer, which is another interesting point about exams. What % of the exam is wrong? With 5 multiple choice answers, 4 of them are wrong. 80% of the exam is wrong. Okay? This is why it's important to show your work and write down what you think is correct. Because if you just go through and start circling answers, odds are you are circling the wrong answer. Write information down. Translate. Okay? The more work that's written on the exam, the less you are working in your head, the better off you will be. Because your head is not a good place to be. That's a nice way to phrase it. Okay? Questions? Got a question back there?
For the first question that you did, the bike now, so when you're like converting and stuff, when it says 75 minutes too, would you subtract that and do like 1 hour over 6?
I don't know the question. Sorry, I must do that for me. It says 75 minutes to commute to work. So how long are we traveling for? What's the time? It takes 75 minutes to travel. If it takes you 75 minutes to get here, what should the time be that you use? Oh, I see what you're saying. 1 hour and 15 minutes. You could go through and make it a complex unit in 1 hour and 15 minutes. Okay? Or you could take 75 minutes and convert it to hours. So there's multiple ways to go through and solve that question. Based off the way that we've talked about it, what's kind of written up on the board there is how you should approach it.
Yeah, I did the 1 hour
Okay.
over 60 minutes, but then with the 75 minutes, would you subtract that one?
Okay, let's work that question in just a second. Bree, you got a question about this one?
Yeah.
Will you give us space on the test to do all that, or are we going to?
For the show your work sections, there is a space where you can write your work. Some people write really big. You may need more space. For people in this room, raise your hand. I'll come give you more paper. For those of you in the testing center, they've got scratch paper. Use their scratch paper. Okay? Other questions? Yes?
If we don't write like the formula at the top, like for the show your work part, do you get like
So-
points taken off?
For the show your work part, if you circle the answer, at best you get 1 point out of 5. Even if it's the right answer. Okay? Because it says, show your work. What I'm grading is the work. I don't care about the answer. This one doesn't say anything about show your work, and it shows up in the straight multiple choice. There is no show your work for this one. Why? Because it would be writing down the formula. You're writing down excess information, and then you're just showing the rest of that. It's a pretty boring question to show your work for. Other questions? Okay. Let's do it this way. We need a little bit help. 14.5 miles per hour. 75 minutes. And the question is distance?
Yeah, how many miles?
Distance in miles. That's all the notes I'm going to write out of this. And I would recommend that when you're going through and doing a show your work question, write this information down. Pull that information out so you can work with it. To start off a conversion question, what do you need to do? What do you want for your final? Don't do this to me. Okay, we're still good. I already forgot. Units that you want on the right. What units do we want? Okay. What units do we start with? Here's a questionable thing. We got two different things to start with. Okay. So take your pick. I'm hearing miles per hour. Why do you want to start with miles per hour?
Because you can convert it down to minutes.
I mean, yeah, but I could convert 75 minutes up to hours. Why start with the miles per hour?
Because you want miles in the answer. So get it by
What do we want in our answer? Miles. So let's go ahead and start with something that has my answer in it. It's a reasonable guess. Right? It has no bearing whatsoever on what we start with, or which is correct or more correct to start with, but it gets us closer to that idea. Okay? So where do we want to rewrite that? Okay? We just talked about this, 14.5 miles per hour. So let's see if I can line this up. I want miles to show up where? In the numerator, because that's where it shows up in the answer. Which means my hour needs to show up on the bottom. Where does the 14 show up? In front of miles. Trained a few of you already. Good. What shows up in front of hours? 1. Is 14.5 miles per hour the same thing as miles? No. So what needs to happen? I need to do some kind of conversion. What am I hoping to happen?
Cancel out.
I just want to cancel hours. What should show up on the bottom of this calculation? Why are you putting in minutes?
So that we can figure out.
Cancel hours. Conversion.
To cancel hours, all I got to do is write hours. I put in minutes. I now no longer have miles. I have miles per minute.
Because we know a conversion of 1 hour to 60 minutes.
Okay? So what you're doing is propagating further than you need to. Do we know how many hours it takes? It says 75 minutes. Do we know how many hours? By doing a conversion, you can convert minutes into hours. Okay? That is a conversion that you can include in this calculation. Do we know the hours? No. Okay? Do we know a time that we could put in there, a time unit that could replace hours? What is the time unit we're given? 75 minutes. So I can include minutes here. We now have a problem though, because if I go through and do this calculation, what unit do I end up with? Miles times minutes per hour. That is not miles. Okay? So I have a problem here. Okay? And this is a tricky part. What do I put on the bottom? What do I put on the bottom? 1. If I put in 60 minutes, is it really 75 minutes? Is that the time it took me? No, that's 75 minutes divided by 60 minutes. That is not the time it took me. It is 75 minutes divided by 1. If I put any other unit or number underneath that, it is no longer 75 minutes. Okay? And my conversion units or work is now incorrect. Okay? So by putting this in, I do have the time set up where the time can potentially cancel. Unfortunately, the time unit cannot cancel directly. So if it can't cancel directly, what do I need to do? I need to put in another conversion. And in that conversion, what needs to happen?
Cancel hour and minute.
I need to cancel hours, so let's drop the hours in up top. When I put the hours in up top, now that cancels. What unit should show up on the bottom? Minutes. Do I have a conversion between minutes and hours? What is that conversion? 1 hour is 60 minutes. Okay. It is setting up your work properly. We can't just drop the 60 minutes in on the other side. Mathematically, do you get the same answer? Yes. Unit-wise, you don't. So that is why we separate this out to track the units. The units are the most important part. Because as soon as you start skipping steps and saying, well, I know I have to divide by 60, so I'm just going to put 60 in, that's great. Your brain is functional. That's phenomenal. I'm going to tell you, in 3 or 4 weeks, I'm going to remove your ability to do it inside your head. If you don't have that ability anymore and you haven't spent the time to set up the proper conversion work, you now have no way to solve the question. You're punching random numbers into the calculator. And as I just addressed, random numbers into the calculator show up as an answer. Okay? So you need to follow the work. Okay? Most people do not like this format. When we go through and solve this, you'll notice that most people will probably write 75 minutes out front, followed by your 1 hour over 60 minutes, followed by 14.5 miles per hour. But they changed the order. That can't possibly be correct. What's a fun property of multiplication and division? It doesn't matter the order in which you do it. Okay? I will get the exact same answer. No difference between those answers. Okay? So depending on which method you're more comfortable with, you can start with your complex unit of the miles. Okay? Or you could start with your 75 minutes and slowly just start to work your way through and make those conversions as best you can. Okay? This is where that avoid formulas at all costs kind of idea comes from. You're used to using a formula because mathematics, it doesn't matter. I can just plug it into a formula. Physics, a lot of people just memorize formulas. Next time you work a physics problem, track the units. All of those equations you memorized for distance, velocity, all of that fun stuff are all out of units. There is no formula. It's a unit calculation all the way through. Okay, I think there was a hand here first, and then we'll go back.
So if we can do the purple, why can't we move the 1 hour over 60 minutes if you would get the same thing? Because like 1 hour over 60
So
minutes.
here's the issue that I was addressing with what a lot of people were asking me to do. What you wanted to do was this. Mathematically, you get the correct answer. What are your units?
Miles per minute.
Miles per hour. We never canceled the hour unit. Mathematically, you get the correct answer. You did the work in your head and you forced numbers into proper places that gets you that number. The number is meaningless if you don't have the units to track. Okay.
Could we put 1 hour over 60 minutes right there instead of 75
Okay,
minutes?
so could we go through and write 1 hour here? Absolutely. What would our units now be? Miles per minute. Is that my final answer? No, so what could I do? I need minutes to show up in that next calculation. And I want what units underneath? Nothing. So just a 1. Do I have some number in my question that tells me minutes with no other information? 75. Okay. So the order in which you do those calculations is irrelevant. The units you put in, very, very important. Okay? And I will tell you on this exam, okay, you can get lucky with just punching into your calculator because your brain is already doing a lot of these calculations. Okay? Really try and focus on setting up the work properly. Okay? And yes, I am breaking you to do this. Okay? But it's for a good cause. I'm a masochist. No. It helps later on. Right? It is masochist. Cause pain.
Sadist.
Sadist? Okay. Oh, masochist is the other way around, huh?
Yeah.
Yeah. Questions? Okay. Does that cover your question now in like 6 different ways? Okay. Whoops. You'll notice we've got to watch out for decimal points, because it didn't look like I drew that very carefully. Okay, so let's do another one. Solve it for me. Start recording again. So we've got our basic work set down. For all show your work questions, okay, this I can't stress enough. Okay, and this goes for all questions in general. Multiple choice answers. There is no penalty for guessing, which means every Scantron I get back, because it's 35 questions, question 1 through 35 should have a single bubble in every single one of those answers. If there is not, you will probably hear me say, hey, wait, come back here. Guess. Okay? If you guess or don't guess, leave it blank, what you are telling me is you do not deserve points. That is verbatim what is coming out of your mouth towards me. I don't deserve any points. If that's really true, fine. I won't give you any points. Okay? But if you guess, you're at least saying, I read the question, I just don't know what's going on. If you guess right, hey, cool, good job. I'll give you points. Okay? Show your work questions. Okay? These get a little bit trickier, because what do you need to do? Show your work to get points. What have I shown already? Work. Guess what? There's points. Don't leave it blank. You leave it blank, you are, again, literally telling me I don't deserve points. Okay? Nobody in this classroom does not deserve points right now. You all sat through me yelling at you. Okay? You deserve points. Just give me the evidence to make you, or to make me give you points. So, how do we then solve this? Well, we'd go through and say, I need to do a conversion here. Centimeters needs to become inches. Oh, I know that conversion, right? 1 inch is 2.54 centimeters. Okay? Everybody so far okay? Okay. The well may very well be that you see centimeters cubed. And that says just centimeters. Oh, that's easy to fix. And you're wrong. Okay? This is the trap with volume. You cannot just drop the cube in there. What happens? You are cubing the entire thing. So by cubing inches, you are also cubing 1. What is 1 cubed? 1. So that doesn't have a problem. By cubing our centimeters, you are also cubing 2.54. Is 2.54 cubed 2.54? No. There's your trap. Okay? You can't just drop an exponent in. You have to process it all the way out. So, there's a couple ways to go through and approach this. One I just showed, drop the cube on the outside and go through and solve that all the way through. The next way is, do you know, let's erase some numbers here. You're saying centimeters cubed and inches cubed. Do we have a conversion between centimeters cubed and inches cubed? No. The conversion we have is centimeters to inches. I don't have the cubic one. So just like we've done with our previous questions, we go, well, this conversion doesn't work. So the only one I've got is centimeters to inches. What unit do I have after running this single calculation? Centimeters squared times inches. Okay. The centimeter cancels, and that, or one of the centimeters cancels, and we end up with squared. Is centimeter squared inches cubed? No. So what do I need to do? I need to do another conversion. I'm trying to get inches in my numerator and centimeters on the bottom. Do I have a conversion factor between inches and centimeters? Yup. Now what's my unit? centimeters times inches squared. Is that my final answer? No. So what I got to do? Do it again. And now through each and every single one of these steps, we end up slowly, slowly, slowly converting across to now just inches cubed. Okay. I even warned you. I said it was a trap. Okay. So be careful with your units. Questions?
Why can't you do the way you did that before with the parentheses?
So, other methods on doing this.
Because what if it's like to the 6 or something?
You'd be writing a lot, yeah. So we can still go through this way, and we can drop in that cubed. But this is where you should be careful, is put the cubed here. And at this point, I would say, okay, I can put in that cubed, but I have to do another calculation first. So I would then go through and rewrite this again, 498, what are we, centimeters cubed times 1 inch quantity to the third power becomes 1 inch cubed. 2.5 to the third power is good enough.
Yeah, that's what I had, 16.
Sorry, I lost track of where I was. Centimeters cubed. Now I would punch in my answer into my calculator and do 498 divided by 16.39. Now my units cancel in a single step, if you will, and I have my inches cubed answer. Okay? Both methods work equally well. It's going to come down to what you see being easier to solve. Those of you that are having trouble with conversions, the first method is the cleaner one. That shows you each of the individual steps. Those of you that think you've got this down rock solid, try the bottom one. Just be aware, it's very easy halfway through an exam that you've now lost your brain in to not do the cube of the 2.54. Okay? Questions about what's up there? Okay, I'm going to erase everything. Allegedly, the answer comes out to be 30.3898 centimeters cubed. The calculator spits something out like that. Okay. Depending on the question asked, this may be a Sig Fig question, which means this answer may show up. Is this the correct answer to bubble in? Why not? You have to take into consideration your Sig Figs. Your Sig Figs need to show up as what? 3 Sig Figs in your calculation, which means we can underline our 3 Sig Figs. Take a look at the first insignificant digit. Is it larger than 5? Yep. So we add 1 to that previous digit and we get 30.4 centimeters cubed. There's our final answer. Frick. This is why you write down your work. You get rid of the work and you can already tell I'm doing it wrong. The work is important. Questions? Okay. So, volume. We just talked about some ways to do it. We can use a graduated cylinder. We just talked about a couple days ago looking at squares, length, width, height. It's really straightforward. We can get our volumes. But what happens if you have an irregularly shaped object, like that star? Right. Those of you in geometry or have had enough geometry could probably say, well, what I can do is calculate the shape of the oval, the area of the oval inside, and then figure out the area of each of those triangles on the outside of it, and add all of those up to get the area of that shape. That is one way to do that. How easy is that? Not very easy. Good, I won't ask that question. How about the shape of the crown? That's three-dimensional, okay? Yes, you could still officially go through and solve that, but that's going to be a big mess. How about the shape of that random object on the far right, which I'm actually trying to represent a different phase? How do we measure the volume of a gas? Okay. This is going to become difficult to go through and measure these things. So we need to come up with some way to determine the volume experimentally, quickly and easily, so we can avoid calculations. How can we go through and do that? You all did it with the lab last week. Displacement. Okay. Archimedes set this up for us. This is Mike's history, so I could very well be wrong on this. I think officially it's Wikipedia's history, but okay. An object will displace a volume of liquid equivalent to its own volume. So that means I can start with a graduated cylinder with water in it that I know the volume of. I can then drop the object in. The water level will rise an equivalent amount as the volume of whatever the object was. So what is the volume of that jade object? It's the difference between those two values. Okay, so we just take 50.5 milliliters minus 60.5, and I get an answer of, I always have problems with math. That is 10.5, right? 10.5 milliliters, except you punch that into the calculator and it doesn't tell you 10.5. What does it tell you? Negative 10.5. Guess what answer shows up? Negative 10.5. Okay. Can the volume be negative? No. So you should immediately say, oh, I just swapped those two numbers around and just make it 10.5. Okay. The other way to do this is to remember how we calculate our formulas. It's the difference in volume, okay, which is represented as a delta V. Delta for change, V for volume. That delta very specifically means one thing. Volume final, VF, minus volume initial. What if I look at a delta T? It's the change in temperature, which I would calculate by taking the temperature final minus the temperature initial. The delta always represents the exact same thing. Okay? So if we use that approximation or that equation, if you will, appropriately, your final volume was 60.5 milliliters minus your 50.5 milliliters. You still end up with the correct answer. Shh. I did not make that mistake. It's recorded. Dang it. Okay. And it was 50.0. God, freaking man. Don't have a day like this on Thursday, please. Okay. Questions on that? So that works for solid objects. How do we measure, say, the gas coming out of that bowl? That is apparently an actual art exhibit, by the way, too. We can still do a volume of gas by displacement, but we have to do a very special container trap system to do this. Because as soon as we push the gas into our liquid, what does the gas then do? You open up that soda can that has all that gas in the liquid, what happens to it? It leaves. Okay, well, if it leaves our container, we can't measure the volume easily. So we end up building a trapped system where the gas comes across. So what we're doing is doing some kind of a reaction over here that produces gas. The gas comes into that chamber and pushes on the liquid. Well, if it pushes on the liquid appropriately, what happens to the liquid then? It has to displace somewhere. That's where our straw comes in handy. The liquid is displaced up the straw and out to a proper measuring container. A beaker is not a proper measuring container, but this is the book figure. Okay? So we could then measure by displacement the amount of gas. Okay? Calculation ends up being the exact same. Okay? So does that now help you with that question that you were wondering about? Good. So all you're doing is looking at your initial and final volumes, run your calculation, works out pretty nicely. I do object to this slide, though, or this image. We have to be very careful with this reaction or this system. Okay, we have to make sure that this flame and our beaker over here have a significant distance between them. This distance must be relatively large. Why? What was that? Why? Okay, good question. Why? I was going to ask you that, but you got to it first. Okay. What happens if we take a balloon and heat it up? Don't tell me it pops. Before it pops, what does it do? It expands. Okay. As we increase our heat, our gas moves more. As it moves more, it takes up more volume, which means instead of measuring just the volume of the gas particles, we're measuring the volume of the gas particles plus their energy associated with it. We need a large distance there so that when we get to the point of measuring the volume, what we're measuring is the gas at room temperature, not heated. As soon as we have that heat too close, we're now measuring the combination of both the actual particles and a measurement of their energy. The more energy they have, the larger the volume. So depending on what you're trying to do, you have to be very careful with your experimental design. So one way that you could fix this would be measure the temperature. Okay? Stick a thermometer into your reaction container, which would mean we'd need a third hole. And we could put a little thermometer in there. This is a thermometer. There's its little bulb. Okay? And we would want to measure that temperature. What should happen to the temperature inside that container? It should stay the same. The moment it starts to increase, we're now measuring the energy of our particles as well as the particles. Okay? So we have to make sure that that temperature stays constant. As long as it stays constant, then we're measuring the volume of just the gas. Okay? It's the first time anybody's actually cared enough to ask about that. So thank you. Okay, it's still connected. Next part, density. Okay, which weighs more, a pound of lead or a pound of feathers? Okay. This is always the fun little question to throw at, your little kids, siblings, some stuff like that. Which weighs more? And they go, oh, the pound of lead weighs so much more because a pound of feathers is so easy to lift. Okay? It's an interesting psychological question, believe it or not. There have been all sorts of weird studies on it. Okay? They weigh exactly the same. They weigh a pound. Why is our natural inclination to say the pound of lead weighs more? It's more dense. There's this extra feature in it of density. That density, so that when we compare a feather and an equally shaped sized thing of lead, the lead weighs more than the feather. Okay. But the mass is identical here. Okay. So we have this psychological mind game going on with us on what's happening with density, and ultimately our ability to interpret it. So what density measures is not just mass or volume, but rather the relationship between them. It gives us the relationship between mass and volume. And when we look at lead, lead is much more dense. For an individual volume, it has a much larger mass than a feather. Okay? So it's that secondary interpretation that takes a little bit of effort on our parts, or a little kid's part, to interpret and understand. Okay? So kind of a neat little feature on this. Okay? Ultimately, what is density giving you?
Weight per 1 right? Or 1.
Okay, so there's an interesting statement to make. Okay, it's giving you something in centimeters cubed, is what you'd be thinking of if we were going to use our distance measurement for volume. Okay, or meters cubed. What else is it giving you? Grams or kilograms. So let's say the density of lead, 8.4 grams per centimeter cubed. Anybody know the density of lead? Good. You can't challenge me. What does that give you? Weight over volume. What does that give you? Density is now a very special thing that we've been talking about. That's exactly what it is. Yeah, it's mass per volume. But what is special about having a mass per volume relationship? What's that? What's special about having 2 units, particularly one in the numerator and one in the denominator? I have a conversion factor. I can now convert centimeters into grams, or centimeters cubed into gram by using the density. I can find, or I now have the relationship that allows me to convert a mass into a volume, or a volume into a mass. Density is merely a conversion factor, and that's how you should be using it and thinking about it. Just like speed, not the drug, the unit, 14.5 miles per kilometer. Speed, a measurement of distance over time. It allows us to convert distance and time. What's happening here? We can now convert mass and volume. It's the same concept. Right? And we have to be careful with it because we can put that 8.4 either in the numerator or the denominator, depending on what we're trying to convert. So if I remember correctly, not quite yet. Units for density, okay, our units may change. So we just looked at one example of grams per centimeter cubed. When we talked about centimeters cubed, the centimeter cubed is also equal to 1 milliliter, the same thing. Depending on what phase we're looking at, we might see different units pop up. Why? When we look at a solid, how would I draw a solid? So this is my first molecule of my solid. Where would I draw the next one? Right next to it. Where would the next one be? All right next to each other. Each of those now occupy a volume and a mass. What volume is unoccupied? Large or small? Very small. So we take a mass and we divide it by the volume. If the volume is incredibly small, what happens to our measurement? We get a really big density. What happens when we move to a liquid? There's our first particle. Somewhere further away. What happens to the volume? Okay, our volume in this case stays the same, but what's happening to the mass? Can I fit as much mass into it? Nope. So what happens to the density? It gets smaller. What happens when we move to a gas? I draw on my single particle of a gas. Where's the next particle? Somewhere really, really far away. So I'm now trapped in the same container. How many particles can I fit into it? Not much. So what happens to the density for our gas? Even smaller. So we expect our density to shrink as we change our phases because we're putting less mass in the same area. Okay? So why might that cause us to change our units? Well, if I look at a solid in grams per milliliter, when I shift to units, our liquid, we do get a decrease in our density. It should be smaller, but how much smaller do we get? Okay, if you think back to the images that we drew out for our solids, liquids, and gases, there's really not that much of an increase in volume as we move to a liquid, okay, or decrease in the amount of particles within it, which means that we get just a slightly smaller value, but because it's not that much smaller, we usually stick with the same unit. What happens when we move to a gas? It now becomes a lot. Get it? A lot smaller. It usually becomes so much smaller that we now change our unit. Okay? So that could shift to being milligrams per milliliter. So we don't change the volume, but we change the mass to being a smaller mass. Why would we change the unit? So we got something that is 0.98, if we looked at water, grams per milliliter. Ooh, let's not look at water. That's a bad call. Ignore that I said water. Water's a tricky one. Because we now move to a liquid, we're probably looking at something that's 0.95 grams per milliliter. When we move to the gas, 0.0095 grams per milliliter. Why would I change the unit? I'm tired of writing the zeros. So all I do is shift the decimal, and by shifting the decimal, I can change the unit. I can change that prefix. Okay, that is the only reason why we would change it. It's a personal preference. Okay? Questions on density? Let's work with it. Dang it! Not yet. Densities of some common substances. So we got a big list of common substances and their densities. How many of those should you memorize? Wow. All of them, huh? What the heck? These densities are wrong. Well, the one that I would tell you to memorize is wrong. That's fun. You should memorize the density of water. And the density of water is not the exact same density as ethyl alcohol. It's 1.0 grams per milliliter. Why should you memorize it? Not only is it easy, but water shows up everywhere. All of our chemistry, all of our reactions are going to be run in water. It's helpful to know that density. Okay? So we now have some containers, our graduated cylinder on the far right with a whole bunch of different things in it. 3 solids, 3 liquids. What can you tell me about the density of the third solid, purple solid? It is the most dense. Why is it the most dense? It's sunk to the bottom. What can you tell me about the density of water? Lighter is a bad word. Less dense than, whoops. What is it less dense than? Water can't be less dense than water.
The object.
Whatever's underneath it. So what is underneath it? Okay. L2. It is less dense than L2. Hence it sits on top of L2. What else can you tell me about it? Didn't want you to say that yet, but it is also less dense than L3. S3. How do you know that? S3 is underneath it. What else can you tell me? Okay, more dense than, I'm running out of colors. Shh, how do you spell? This day sucks. More dense than, I heard, L1. Why? Okay, L1 is above water. What else is it more dense than? S1. Okay, we've covered everything except for one last object, S2. Okay, a couple people have jumped out above the rest of the class, so I don't think the rest of the class is listening, so you guys can't talk. Well, people that said the answer can't talk. S2, more or less dense than water. Or what your classmates have been suggesting, saying the same. Water is less dense than S2. Okay. Not the same. Definitely not more. Why is it not more? Okay. Most of the water is above S2. Okay. So S2 is just sitting on top of the S3 along with water. Okay. Somebody brought up this issue of, is it the same density? No, because S1 is technically floating on top of the water. It would float in the water. So if it had the same density, our S2, this is going to look a bit silly. Maybe we can do it this way. Our S2 would be in the middle of the water. Okay? It would go to wherever you placed it in the water. Okay? Questions? Let's run some calculations. What is the density of a platinum nugget that has the mass of 224.50 grams and a volume of 10.0 centimeters cubed? Okay. First one I want it in is grams per centimeter cubed, and I also want it in pounds per liter. It was a good one to practice on. I'm going to say our final answer, we want pounds per liter. Hopefully you can all figure out the grams per centimeter cubed by just doing that calculation. One of the things that everybody wants to do, what is the formula? What is the formula for solving density? I would argue that's wrong. What do I want as a final answer? Grams over centimeter cubed. Do I know the grams? What are my grams? Oh, whatever. Some number, blah, 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 grams. Okay? That's the number I've got. Okay? I can't put anything underneath it because is there anything underneath it? No. So I now need to bring in my next conversion. Do I want anything to change to the grams? No. So whatever shows up in my next conversion had better not have grams in it. What does need to show up in that? Our volume of centimeters cubed. Do I know the volume?
Yes.
What do I know about my centimeters cubed? It's 10.0 centimeters cubed. What should show up on top? Why not any other number? That would be changing the volume. The volume is 10.0 centimeters cubed. If I bring in any other number or any other unit there, that is no longer a true statement. Okay? If you go through and solve according to the equation, what do? You take your mass, which I screwed up in massive amounts of numbers, and you divide it by the volume. What did I just set up as far as the work goes? That exact same thing. That equation that you memorized, don't need to memorize. Follow the units. The units got you there. There was no equation to memorize. What you're doing is being very careful with how you set up the question to solve the question without memorizing any equations. So, let's see if I can write it correctly this time. 224.50 grams, 0.0 centimeters cubed. A question was brought up, do I need to cube that 10? No. The centimeter cubed is the unit on the number 10. It's already been cubed. You don't need to worry about cubing that. The only time you've got to worry about it is when you're trying to convert centimeters cubed into something else, which may very well happen in this next part. So we'll address that when it comes up. What units do I currently have? Grams per centimeter cubed, right? Is that my answer? No. What do you want to fix first? I heard grams, I think. So grams does not show up in my final answer. So where does grams need to show up in my conversion? On the bottom. What do I want it to convert to? Pounds. Ooh, I didn't memorize that. Man, that sucks. It's given to you. That's a good call. What number shows up in front of pounds? Why? Because according to our conversion, the 1 shows up in front of pounds. 454 grams. What's our unit now? Pounds over centimeter cubed. Is this my answer? Am I closer to my answer? Good. Now what do I have to do? I need centimeters cubed to cancel. Okay. Ideally, it would cancel and become liters. Why did I put the liters on the bottom? Liter shows up on the bottom in my final answer. Okay. Do I have that direct conversion? No. So, do I have a conversion for centimeters cubed? Anything else?
Yes.
Milliliters. What is the conversion between centimeters cubed and milliliters? 1 and 1. Do I need to cube the 1? No, this is a direct relationship. It's 1 measured value, centimeter cubed, equals 1 measured value, milliliter. Okay. Am I at my final answer? Gosh. Okay, so what has to happen? Milliliters and liters. Do I have that conversion factor? You better. You got that one memorized. Milli means 1,000th, thank you, 10 to the negative 3. Our power of 10 goes in front of our liters. 1 goes in front of our milli. Punched into the calculator, we now have our conversion across to pounds per liter. Or, yeah, pounds per liter. Okay. We are out of time, so if you got questions, just come up and talk to me. I won't delete this, but I'm pretty sure